Hello, let's learn a chapter quadratic equations. Before we proceed, let's revise. Number 1. A polynomial in one variable having degree 1 is called linear polynomial. Number 2, a polynomial in one variable having degree 2 is called quadratic polynomial. Okay. Number 3, a quadratic polynomial which equal to 0 is called quadratic equation. Number 4, an equation in a form of ax square plus bx plus c equal to 0, where a, b, c belongs to R and a is not equal to 0 is called standard form of quadratic equation. And number 5, the value of variable for which an equation is satisfied is called root of that equation. Okay, these are the basic points related with equations, and here we are going to learn quadratic equations. Now let's apply all these points in practice sets in a chapter quadratic equations. Let's see practice set 2.1. Practice set 2.1 question first. Write any two quadratic equations. It is an open-ended question. You may give any example of quadratic equations. Question first, solution. Okay, as we are interested with any two examples of quadratic equations. Let us suppose x square minus 5x plus 7 equal to 0. That it is first example. Second example, 7y square plus 5y plus 15 equal to 0. Okay, these are two examples are sufficient. Let's see question second. Decide which of the following are quadratic equations. Question second, sub question first, solution. Here, given equation is x square plus 5x minus 2 equal to 0. Here you may note the variable is x and the highest index of x is 2. Means this is an equation with one variable having degree 2. Okay, therefore it is an equation with one variable having degree 2. Having degree 2. Therefore, it is a quadratic equation. Okay. Similarly, let's see number 2. Solution. Okay. Second equation you give y square equals 5y minus 10. Therefore, it will be y square minus 5y plus 10 equal to 0. And therefore, it is an equation with one variable, which is that variable y. Here variable was x. Okay, here variable is y. Having degree. Degree means maximum power of that variable. That is 2. And therefore, it is a quadratic equation. Number 3. Solution. Here, equation is y square plus 1 upon y equal to 2. To convert this equation in linear form, we need to multiply LHS as well as RHS by y. And therefore, by multiplying every term by y, we are going to get y into y square gives us y cube plus y into 1 by y. Y will get cancelled, leaving behind 1. That equals 2 into y means 2y. And therefore, it is y cube minus 2y plus 1 equal to 0. Therefore, it is an equation with one variable, which is that variable y, but having degree 3. Degree means maximum power, means highest index of that y is 3 and not 2. Therefore, it is not quadratic equation. It is not quadratic equation. Let's see fourth. Number 4, solution. Here, the given equation is 3m square equals 2m square minus 9. Therefore, it will be 3m square minus 2m square plus 9 equal to 0. And therefore, 3m square minus 2m square gives us m square plus 9 equal to 0. And therefore, it is an equation with one variable. Which is that variable? M, having degree 2, because highest index is 2. Therefore, it is a quadratic equation. Okay? Number 5, solution. Here, given equation is P in bracket 3 plus 6P equals minus 5. First of all, let's simplify it. Therefore, P into 3 gives us 3P. P into plus 6P gives us plus 6P square equal to minus 5. Now, let's rearrange all these terms in descending powers of variables. Therefore, it will be 6P square plus 3P. On transfer of that minus 5 from right to left, it gives us plus 5, that equal to 0. And therefore, it is an equation with one variable. Which is that variable? That variable is P, having degree. Degree means maximum power, maximum index of variable, that is 2. Therefore, it is a quadratic equation. Okay, now let's see number 6, solution. Here, given equation is x square minus 9 equal to 13. Okay, and therefore it will x square minus 9 minus 13 equal to 0, and therefore it would x square minus 14 equal to 0. Okay, if we write it in standard form, we get x square plus 0x minus 14 equal to 0, because here a term containing x is missing, and such a term we can write with its coefficient 0. That's why this equation will be x square plus 0x minus 14 equal to 0, and therefore it is an equation with one variable. Which is that variable? That variable is x, having degree 2, and therefore it is a quadratic equation. Okay, it is a quadratic equation. Let's see question 3rd. Write the following equations in the form x square plus bx plus c equal to 0. Then write the values of a, b, c for each equation. Question 3rd, sub question 1st, solution. Here, given equation is 2y equals 10 minus y square. We are interested with a standard form, means x square plus bx plus c equal to 0. Okay, here variable is y, that's why it should be in a form of ay square plus by plus c equal to 0. Okay, and therefore let's rearrange terms. Minus y square is at right, that's why on transfer towards left we get y square. At the left we have already a term containing y, that's why let's write it as plus 2y. On transfer of 10 from right to left we get minus 10 equal to 0. Now it is in standard form, and therefore comparing it with ay square plus by plus c equal to 0. Instead of saying x square plus bx plus c equal to 0, we are saying that ay square plus by plus c equal to 0, because here variable is y. Okay, comparing it with ay square plus by plus c equal to 0, we get a equals, here a is 1, b equal to 2, and c equals minus 10. Okay, number 2, solution. Here given equation is x minus 1 its square equals 2x plus 3. Okay, first of all let's simplify it. Now LHS is in a form of a minus b bracket square, and we know that a minus b bracket square equals a square minus 2ab plus b square. Using that identity we can write square of the first term is x square minus 2 into first term into second term plus square of the second term, that equals 2x plus 3, and therefore it will be x square minus 2 into 1 into x gives us minus 2x, and square of 1 is 1, and let's transfer all non-zero terms from right to left. It gives us minus 2x minus 3 equal to 0, and therefore x square minus 2x gives us minus 4x plus 1 minus 3 gives us minus 2, that equal to 0. Now it is in a standard form, and therefore comparing it with ax square plus bx plus c equal to 0, we have a is the coefficient of quadratic term, that is 1, b is the coefficient of linear term, which is minus 4, and c is the constant term, that is minus 2. Then number 3, solution. Here, yes, he gave x square plus 5x equals minus in bracket 3 minus x. Therefore, x square plus 5x equals minus sign will be applied with each and every term which is in bracket minus 1 into 3 gives us minus 3 and minus 1 into minus x gives us plus x. Let's transfer all non-zero terms from right to left. Therefore it will x square plus 5x plus x from right to left gives us minus x and minus 3 from right to left gives us plus 3, that equal to 0, and therefore it will x square plus 5x minus x plus 4x plus 3 equal to 0. Now it is in standard form, and therefore comparing it with x square plus bx plus c equal to 0. Yes, a is the coefficient of quadratic term, means a term having degree 2 and that coefficient is 1. B is the coefficient of linear term, which is 4, and C is the constant, that equals 3. Number 4, solution. What's question 4th? It is 3m square equals, yes, 3m square here, 3m square equals 2m square minus 9, and therefore 3m square minus 2m square plus 9 equal to 0, and therefore it is m square plus 9 equal to 0. Now here we have quadratic term and constant term, not having linear term, and we know that while writing missing term we are going to consider its coefficient as 0, and therefore it will be m square plus 0m plus 9 equal to 0, and therefore comparing it with standard equation am square plus bm plus c equal to 0. Here we are going to consider m as a variable because given equation contains m as a variable. Okay, a equals coefficient of quadratic term, which is 1, b is the coefficient of linear term, which is 0 in this case, and c is the constant term, that is 9. So question 5th, solution. Here p in bracket 3 plus 6p, that equals minus 5, and therefore p into 3 gives us 3p, p into plus 6p gives us plus 6p square equal to minus 5, and therefore it will be 6p square plus 3p minus 5 on transfer from right to left we get plus 5, that equal to 0, and therefore comparing it with ap square plus bp plus c equal to 0, we get a equals coefficient of quadratic term, that is 6, b equals coefficient of linear term, that is coefficient of p, which is 3, and c is the constant term, which is 5. Number 6. Okay, solution. Here, yes, x square minus 9 equal to 13, and therefore x square minus 9 minus 13 equal to 0 gives us x square minus 22 equal to 0. Okay, and therefore it will x square plus 0x minus 22 equal to 0, and therefore comparing it with ax square plus bx plus c equal to 0, we can write a equal to 1, b equal to 0, and c equals minus 22. Question 4th. Determine whether the values given against each of the quadratic equations are roots of the equations. Okay. Question 4th. Sub-question first. Solution. Here, given equation is x square plus 4x minus 5 equal to 0. Okay. And given values are x equal to 1 or x equal to minus 1. And therefore, for x equal to 1, LHS is x square plus 4x minus 5. Okay, here we are going to put x as 1, and therefore LHS will become 1 square plus 4 into 1 minus 5. Okay, 1 square is 1 plus 4 into 1 gives us plus 4 minus 5. 1 plus 4, 5. 5 minus 5 gives us 0, which is RHS, and therefore in that case LHS equals RHS, and therefore x equal to 1 is the root of given equation. Which is that equation? X square plus 4x minus 5 equal to 0. Now, for x equals minus 1, LHS equals, let's put x as minus 1, and that's why this equation will become minus 1 its square plus 4 into value of x we are going to put as minus 1 minus 5. Square of minus 1 is 1, and plus 4 into minus 4 gives us minus 4, and that minus 5 as it is. Now minus 5 plus minus 4 gives us minus 9. Minus 9 plus 1 minus 8, which is not equal to RHS, and therefore LHS is not equal to RHS, and therefore x equal to minus 1 is not the root of given equation. Which is that given equation? X square plus 4x minus 5 equal to 0. Sub-question second. Solution. Here, given equation is 2m square minus 5m equals 0. Let's call it as equation 1. And therefore, for m equals 2, LHS equals 2m square means 2 into 2 square minus 5m means minus 5 into 2. Okay, then square of 2 is 4, 4 2s are 8, minus 5 2s are 10, 8 minus 10 minus 2, which is not equal to RHS, because RHS is here 0, and therefore LHS is not equal to RHS, and therefore M equal to 2 is not the root of given equation. Which is that equation? 2m square minus 5m equal to 0. Now, for m equal to suggested value for m, which is 5 by 2, LHS equals 2m square, means 2 into 5 by 2 square, minus 5m means minus 5 into 5 by 2. Okay, and then in this case 2 into square of 5 is 25, square of 2 is 4, minus 5 into 5 by 2. Okay, now 2 ones are 2, 2 twos are 4, which gives us 25 upon 2 minus 25 upon 2, because minus 5 into 5 gives us minus 25 upon 2, which is equal to 0, and therefore LHS equals RHS, and therefore M equals 5 by 2 is the root of given equation. Which is given equation? Given equation is 2m square minus 5m equal to 0. Question 5th. Find k if x equal to 3 is the root of equation kx square minus 10x plus 3 equal to 0. Question 5th. Solution. Here, as x equal to 3 is the root of equation. That given equation is kx square minus 10x plus 3 equal to 0, and therefore substituting x equal to 3 in given equation, we get given equation is kx square minus 10x plus 3 equal to 0. We get k into x square means k into 3 square, minus 10x means minus 10 into x, and value of x we decided to put as 3. Okay, plus 3 equal to 0, because already he gave x equal to 3 as a root, and root is the value of variable which satisfy the given equation, and therefore it will k into square of 3 is 9, means it will 9k, minus 10 into 3 minus 30 plus 3 equal to 0. According to Bodmer's, first of all we will perform operations of division, multiplication, then addition and subtraction. Okay, now 9k will be as it is because it contains variable, minus 30 plus 3 gives us minus 27, those equal to 0, and therefore 9k equals 27, and therefore k equals 27 upon 9. 9 ones are 9, 9 threes are 27, and therefore k must be equal to 3. Question 6. One of the roots of equation 5m square plus 2m plus k equal to 0 is minus 7 upon 5. Complete the following activity to find the value of k. Okay. From given information we note minus 7 upon 5 is the root of quadratic equation 5m square plus 2m plus k equal to 0. Therefore put m equals minus 7 upon 5 in the equation. Therefore 5m square and value of m is minus 7 upon 5, that's why minus 7 upon 5 its square plus 2m means 2 into value of m minus 7 upon 5 plus k equal to 0. Okay, it gives us, what will it give? 5 into square of minus 7 is 49 and square of 5 is 25. Okay, plus 2 into minus 7 gives us minus 14 upon 5 plus k equal to 0. Now here you may look 5 ones are 5, 5 fives are 25. Okay, here square of minus 7 was 49. Okay, and 5 ones are 5, 5 fives are 25. That's why resultant will be 49 upon 5. Okay, and here 2 sevens are 14. Okay, minus 14 upon 5. 49 plus minus 14 upon 5 plus k equal to 0. Now in these two fractions, denominators are same. 49 upon 5 minus 14 upon 5, they have denominator 5, 5. That's why there will be the operation in numerators. Plus 49 plus minus 14 means we have to subtract 14 through 49. 9 minus 4 gives us 5 and 4 minus 1 gives us 3. 35 upon 5. Okay, and 35 upon 5 plus k equal to 0 means 5 ones are 5, 5 sevens are 35. Means actually it must be 7 plus k. Okay, it must be 7 plus k equal to 0 and therefore k equals minus 7. Okay, let's erase those rough work. Okay, hence activity is complete. Question second, sub question fourth. Solution. Here given equation is x plus 1 upon x equal to minus 2. First of all, let's convert it in linear form. Let's multiply LHS and RHS by x. Therefore, it gives us x into x, x square, plus 1 upon x into x gives us x will cancel. Leaving behind, yes, just 1 equals minus 2x, and therefore it will x square plus 2x plus 1 equal to 0, and therefore it is an equation with one variable, which is that variable x, having degree, yes, what is the degree of this equation? Having degree 2. Therefore it is a quadratic equation. Okay. Similarly, we may solve fifth and sixth. Number 5. Solution. Here Yes, what's that? M plus 2 into M minus 5 equal to 0. Therefore, M into M gives us M square. M into minus 5, minus 5M. Now plus 2 into M plus 2M. Plus 2 into minus 5 minus 10 equal to 0. Therefore, M square minus 5M plus 2M minus 3M minus 10 equal to 0. And therefore, it is an equation with one variable, which is that variable M, having degree 2. Therefore, it is a quadratic equation. Okay, it is a quadratic equation. Similarly, number 6, solution. Here, what's here? Here is M cube plus 3M square minus 2 equals 3M cube. Okay, before deciding whether it is quadratic or not, we must simplify it. Therefore, it will M cube minus 3M cube plus 3M square minus 2 equal to 0. On transfer of those 3M square M cube from right to left, we get minus 3M cube. M cube minus 3M cube gives us minus 2M cube plus 3M square minus 2 equal to 0. Okay, therefore, it is an equation with one variable, which is that variable x, not x here, which is that variable M, having degree 3, and therefore it is not a quadratic equation. Okay, it is not a quadratic equation.